Hello, good evening, guys. Welcome to today's class. This evening, we shall be looking at indices. We're considering mathematics today, and the topic we are looking at is indices. And to start with, we'll start with the laws of indices. And we'll quickly refresh our memory with the aspect we did in our SS1 before we start solving problems on this. You were introduced to laws of indices in year 10, which is SS1. You were introduced to laws of indices. So I'll quickly talk about the law, and after which we'll start looking at examples, the applications of these laws. Okay, to start with, though the arrangement may follow the order that is quite different from what you have in your maybe course books and probably your notes, but we're still dealing with the same thing. To start with the laws of indices, let's look at the first law. We have let's say we have a raised to power m multiplied by a raised to power n. This is in form of a raised to power m plus n. Right from GSS2, when you have something like this, there's a way we approach it, but the law helps us to simplify this. For instance, let's say we have to resolve this y raised to power 5 multiplied by y raised to power 3. What this law is saying is that we can simply get the solution to this by applying this law by saying y raised to power 5 plus 3, and that gives us y raised to power 8. That's the essence of this law. And the second part of this, because this one is talking about power relationship, and we have it in 3 different patterns. The second part is when we have a division. Let's call that one the second part. Let's say we have a raised to power m divided by a raised to power n. That one is in the form of a raised to power m minus n. Let's say, for instance, we have to resolve this p raised to power 6 divided by p raised to power 3. We can easily resolve this by saying p raised to power 6 minus 3, and this will give us p raised to power 3, because 6 minus 3 will give us 3. Okay, now the third one that has to do with the power. Let's say we have let's call that one third one. This one, if you have an expression in form of a raised to power n close bracket n, we can have you know that when we have brackets, a bracket is simply talking about multiplication. Therefore, we can multiply the power. We have a raised to power m, and this third one is talking about. For instance, let's say we have x raised to power 3, that is in the bracket raised to power minus 2. You can easily say x is raised to the power of minus 6. And let me just stop this at this point. I don't want to introduce new law here because we are still going to talk about another law, because we can still express this further, but we'll see it in the subsequent law that we are going to consider. Okay, the first three laws that we've looked at, they are talking about power relationship. If you see, check the first one. Power of A here is M and power of A here is N, and multiplication sign is between the first and the second letter there. That's why we resort to having the addition of power. And the second one, we have division. What this one is telling us is that when we have division here, the power will be subtracted. And the first one, when we have a multiplication, the power will be added. That is the implication of this. Okay, now and the third one, we have a raised to power m into bracket n. That is, we can as well multiply power when we have one in the bracket and the other one outside the bracket. That is what just happened here in the case of this, and we have this. Okay, now we still have some other laws that we'll consider before going straight to example. All this aspect I'm looking at, I want to believe we've done this in our SS1. Like I said, this class is meant for revision for WAEC students and those that are writing JAM, NECO, and the rest. But we need to pick up every topic right from SS1 so that the students from SS1 joining us, they will not miss out. Now the fourth one we are considering is when we have any integer or letter to power of 0 that is equal to 1. When you have any letter, no matter how big the letter is, to the power of 0, the answer equals to 1. We call that one zero index. The first three law is talking about power relationship. This fourth one is talking about zero index. We also have a negative index when a letter is raised to negative power. That is inverse, or you call it negative index, and you can resolve that one to 1 over a raised to power m. So we are going to pack all these laws together. We are going to use them in solving problem, and we can as well have, let me open new page for this. Okay, okay, now let's consider the what. Okay, we've looked at the 51. Let's consider, we look at the 51. Let's consider the 61. Okay, when we have this, when we have expression in this form, we can easily resolve it to a raised to power m over n. But this also have another representation. We can as well represent it like this. That is, the denominator of the power comes to this place. We have the letter here, while the numerator of the power comes outside the bracket here. We can as well have that. We can have a letter in form of that. But take note of something here. If the numerator, if this numerator and the denominator, if they are the same, it means our answer is the letter that is carrying the power. It's as simple as that. That is what I'm saying, is that if you have, let's say we have it in form of this. Let's say we have root n a into bracket raised to power of n. This will give us letter a whenever you come across this. That's how you resolve it, because n divided by n will just be 1. That is what this one is telling us. And when you have something like this, you can see something like this example here. We can have something like this in this case, 27 raising to power 1 over 3 raised to power 2, and you can easily rewrite this as a 27 raised to power 2 over 3. And you know that using the law, we can have something like this. We all know that the cube root of 27 is 3, so we are going to end up having 3 squared, and that will be 9. But there's a simpler way of doing this, that is, we can as well approach this by using this method. If you have 27 raised to power 2 over 3, you can easily say, 27 is 3 raised to power 3, as simple as that, raising to power of 2 over 3. So this can take this one away, and we end up having 3 squared, and that will be equal to 9. We still arrive at our 9. So any of the approach that is very, very simple for you, you can go ahead with it. Okay, now what we've seen so far here is we look at the sixth law of indices. We are going to consider just 6. In your textbook you may have more than this, or even not up to this, but these are the necessary things that I think we need to consider. And on our first page we have the first 5 laws. We started with power relationship. That is when we have a product of same letter carrying different power. We resolve it to addition. We had the power. When we have division of same letter carrying different power, we are going to resolve it to subtraction, as you can see there. Okay, now when we have a letter carrying a power and another power is outside the bracket, you can multiply the power, as you can see in the rule number 3. For the fourth one, whenever a letter is carrying a power of 0, either letter or number, the answer is a unit, that is 1. And when we have negative index, this simply signify that we're going to have inverse or reciprocal of that number or letter carrying the power. Okay, let's now consider some example here. Okay, we also consider this. We just finished explaining this. Okay, let's consider some examples in this case. Okay, let's start with a very simple one. Like I said, we are going to look at past questions from WAEC, NECO, and probably UTME. So those are the examples we are going to be considering. But I need to first introduce you guys to the laws to be used when we are solving the problem. Okay, let's start with this. Let's say we are to simplify this. We have a 0.001 raised to power 3. So we have to simplify this. And how do we go about this? Very, very simple. What we just need to do is that we want to apply one of the laws in solving our problem. So in order to do that, what is in the bracket, 0.001, we can easily rewrite it as 10 raised to power minus 3 using our standard form. This thing is what we're familiar with right from our basic school. And the power outside, we'll still put it there. So if you use one of our laws, I think the third law that is dealing with relationship product of powers, we can have 10 raised to power minus 9. And we cannot stop here. We can as well proceed to use a negative index law when we have 1 over 10 raised to power 9, and this can be our final answer. It's as simple as that. Let's consider another example. Now let's call this one example 2. In example 2, let's say we have this expression 1 over 2 raised to power of x equal to 8. So we have to find x. We have to find x in this particular one. Now how do we find x? Very, very simple. What you just need to do is that simplify everything, that is every digit that are involved, and see how we can relate them. Okay, to start with, what is in the bracket, we can turn this one to 2 raised to the power minus 1. That is a reverse of negative index. So, and have it like this. And this 8 can be written as 2 raised to the power 3. And having that, we can easily do something here. When we apply the third law, we can have this one to be equal to 2 raised to the power minus x equal to 2 raised to the power 3. And as you can see, we have this and this, they are the same, so we can equate their power. Since 2 is carrying minus x as power here, and that same 2 is carrying 3 as power on the other side, so we can equate the power. So equating the power, sorry for that, equates the power. By equating the power, it can have something like minus x equal to 3. That is, this one, take this one away, and having something like this, we can divide both sides by minus 1, so we have x equal to minus 3. So that's the answer to that particular one. Okay, what we've done here is just to apply the laws of indices. Started from here, we reduce this one, starting from here, we reduce this one to 2 raised to the minus 1 and multiplying it by the power of x that is outside. Also, this one is turned to 2 raised to the power 3. We all know that 2 raised to the power 3 equals 8. Okay, and we equate the power by taking the common terms away. That is, these two also go for this. Okay, and by equating the power, we have minus x equal to 3, and dividing both sides by minus 1, we have our x to be equal to 3. Okay, now let's look at another example. We still have some other example that we want to consider. Okay, let's say in our example 3, we have something like 3 into 3 raised to the power x equal to 27. When you come across things like this, don't make a mistake of multiplying the 3 that is in the bracket with the one outside the bracket, because the 3 in the bracket is carrying a power of x which is unknown. We don't really know what that x represents, so you cannot just multiply the 3 outside the bracket with the one in the bracket. What you can easily do here is to apply the law of indices. The 3 outside the bracket is carrying the power of 1. Bracket represents multiplication, and 3 inside the bracket is carrying x, where our 27 is also equal to 3 raised to the power 3. Now we've simplified this. What we just need to do next is to apply the laws accordingly. Now when you have this multiplication sign, you can easily resolve this side to 3 raised to the power 1 plus x, because that multiplication will make us to add our power, the power of the 3, because they are the same thing, so we can add the power. Okay, equate that one to 3 raised to the power 3. So we can equate the power now. Taking this away with this, we can equate the power by having 1 plus x equal to 3, and that will give us x equal to 3 minus 1, and that gives us x equal to 2, and that's answer to that equation. Okay, we can proceed to have as many as possible examples. We are going to have at least 2 more examples, and with that we can call it a day. Okay, now let's say we have another one, example number 4. This one is let's see, that one is 0.25 raised to power x plus 1 equal to 16. That is fantastic. We can easily apply, we can as well apply this law of indices in solving this problem. But before we do that, we need to turn the decimal number to either fraction or a whole number, and the best way to do this is to turn it to decimal number, to turn the decimal number into fraction. Okay, the number that is in the bracket 0.25 is the same thing as 1/4. and we can raise that one to power of x plus 1, and 16 here is equal to 4 raised to power 2. With this, we can easily go further to simplify this further. We can say 4 raised to power 1 over 4 equal to 4 raised to power minus 1, and the whole thing is carrying the power of x plus 1, and this is 4 raised to power 2. So we can still go further to multiply the power in the bracket and the power outside the bracket. So with that, we are going to have 4 raised to power minus 1 times x will give us minus x, while minus 1 times plus 1 will give us minus 1, equal to 4 raised to power 2. So at this point, we can equate the power, and in doing that, this will go for this. So we have minus x minus 1 equal to 2, minus x will be equal to 2 plus 1, and with this we can say minus x equal to 3. Dividing both sides by minus 1, our x will become minus 3 according to what we have in the equation. Okay, let's check another example. This time around, I want us to consider a sample that does not have letters at all, that is just having numbers. Let's look at a sample with just numbers that does not have letters. Okay, let's say we were given something like this, 64. All these questions that we are dealing with, they are WAEC questions anyway. If you have your past question, you can look for them there, or you can look for more to even solve. And 1 over 3. Okay, to just simplify this, it's as simple as anything. We can still apply the knowledge of indices. We can just say our 64 here, our 64, we can turn it to 8 raised to power 2. 64 is 8 squared, and it's carrying power of 1 over 2. Plus our 125 is 5 raised to power 3. The idea behind all this is to just look for what will eliminate the power in this type of question. And with this, these two can take this one away, while this one is taking this one away. So it's as simple as that. This one is an objective question in WAEC past question. So we are going to have 8 plus 5. And that gives us 13. That's an example, I think, WAEC 2018 questions. Okay. We are going to have just one more example, and that one involves our Indical equations. And with that, we will call it a day. But before we do that, if you are just joining us, what we've been looking at is indices, and we've been applying laws of indices in solving problems, and we've discussed all the laws of indices. And we've used them in solving problem. We started with power relationship laws, and we solved some example. We quickly recall that because that is part of what we did in SS1. We also look at some other laws, and we now use them to solve examples. This is our example 1. This is how we handle example 1. You can see it on the screen. This is our example 2. We started from here. You can see how we apply the knowledge of all this law in resolving it in breaking them down and have the value of our x. In our example 3, we did the same thing by breaking the expressions into what the laws of indices can handle. In our example 6, we did the same thing. In our example 5, we did the same thing. In our example 5, we have just numbers without letters. So lastly, we are going to have one more example, and that will be our example 6. And in our example 6, we have Indical equation. We have the equation in form of 5 raised to power 2x minus 26 into 5 raised to power x plus 25 equal to 0. And what we have to do here, we have to find x. X is the question here. How do we go about this? We call this one Indical equation. So how do we go about this? Very, very simple. One thing I want you to know is that this expression here can be rewritten because this 5 is carrying at least power of 2 integers, which in which one of them is unknown. So we can rewrite this by saying 5 raised to power x into bracket 2 is still the same thing. If you recall the third law that we used, in the third law we see how we can multiply the powers together, and that is what is just happening here. Okay, and if you express this as this, we can move on to have this 26 into 5 raised to power x plus 25 equal to 0. And at this junction we need to apply another method that we've not talked about. Okay, let's just represent 5 raised to power x with a letter. Let's say let's 5 raised to power x equal to p. With that we can have a p square minus 26p. Remember, 5 raised to power x now is equal to p. So wherever you see 5 raised to power x, we put p there, that is here and here. Okay, that is what we are doing. Plus 25 equal to 0. With this we have a quadratic equation which we can factorize and have the value of our p and take it back to the expression of 5 raised to power x. So how do we go about this? Very simple. If you look at this quadratic equation, we can simplify this by saying p squared minus 25p minus 1. Okay, let me just say minus p. 1p is also p plus 25 equal to 0. At this junction we can just look at what is common here. We can just say p into p minus 25 because p is common here. That is factorization in quadratic equation. And on this side nothing is common, it's only 1 that is common, so we can just say 1 into p minus 25. Remember, if you open this bracket again, minus 1 times this will give us plus 25 here. Okay, we can easily deal with this. Okay, with what we have on the screen, we can say p minus 1 into p minus 25 equal to 0, and that simply means p equal to 1 or 25. And we are not going to stop here because we made something to be equal, we equated something to p. So remember that we have 5 raised to power x equal to p. So we can say when p equal to 1, you can say 5 raised to power x will be equal to 1. And we can now apply the law of indices at this point. Remember that when we have a 0 as the power of anything, that thing will be 1. So we can as well apply that knowledge by saying 5 raised to power x is also equal to 5 raised to power 0. Remember that 5 raised to power 0 will be equal to 1. Okay, at this junction we can say x equal to 0 by cancelling this. That is when p equal to 1. Okay, what now happens when p equal to 25? Remember, we have two values for p from here. P is either 1 or 25. So we've treated the aspect of p equal to 1. Let's see when p equal to 25. When p equal to 25, we can say 5 raised to power x equal to 25. Therefore 5 raised to power s can be equated to 5 square, and this junction we can take these two away. X equal to 2 is our final answer. Oh, okay. With this, I want to believe we've done something today. But if in case you join us late, or probably you have any question during the course of this, please feel free to drop your question at the comment section, and the question will be attended to. And if you are yet to subscribe to this channel, please do, and always share the link of this channel with everyone in your contact that you think they are writing WAEC, NECO, or UTME, or even Cambridge IGCSE. Or those examinations will be looked into on this channel, and we'll be having our classes at least 3 times in a week, which will be physics and mathematics classes. Please, and if you've enjoyed the class one way or the other, please feel free to subscribe to the channel, and also click on the notification buttons. That is, whenever we're on live video like this and live classes like this, you will be notified. And if you've been blessed, or the value has been added to you with today's class, give me thumbs up at the comment section and let me know through your comment. Once again, thank you for being part of this, and please don't forget to always share this on every group that you belong to. The class is always free. Feel free to share the class, the link, with everyone in your contact. Thank you, and God bless you.